Hey audio students, this is Rajiv and I'm back with another presentation, and this time we're going to be talking about time-based processors. Last week, if you recall, we talked about level-based processors, and specifically we talked about the equalization and compression. Right, so EQs, they affect levels, but they also affect tonality as well. If you're boosting a certain frequency, you're actually increasing the overall volume. And then if you're subtracting a certain frequency, you're actually decreasing the overall volume. And then the compression, if you remember, even though we didn't get into it as deep, but it's basically a dynamic range manipulator. So if you have a lot of fluctuations of volume within your audio track, you can use a compressor to kind of make that audio track a lot more even in terms of volume. But those two things are level-based processors. They impact the level and the volume of specific tracks that you use those processors on. Now we're going to move into the second category of effects, which is called time-based processors. And these are things that manipulate time. So this presentation is really going to focus in on reverb, but the other time-based processors that I'm kind of going to go over in the demonstrations more so than the presentation is delays. So let's get right into it. So we talked a little bit about reverb. And we're going to talk about the definition of what reverb actually is. We'll go into the history of reverb and how things were reverberated before the digital era, right? Before plugins and computers and all that kind of stuff. And then we'll talk about the acoustics. In order to get a good understanding of reverb, we should understand how acoustics work, because reverb essentially is acoustics. You're just manipulating the acoustics of a specific source, right? So that's kind of what that is. And then lastly, we'll finish it up with the parameters of the reverb. And when I say parameters, I mean the knobs that you'll find in a reverb plugin or a reverb box, outboard gear, whatever the case you have. So that's really the whole spiel for today. So let's get right into it. So let's talk about the definition of reverb. A lot of you kind of already know what reverb is going into the class. Some of you may have never heard of it before, but it's something that's pretty known, but what it is basically a dimensional space, right? So when you record your narration, or if we record like a sound effect or whatever you record, instruments, you can, the recording when it comes back, especially if you did a close mic recording, is going to sound fairly dry. There's not going to be any kind of echo, there's not going to be any kind of reverb, there's not going to be any kind of space involved, because you probably recorded it from the source directly into the microphone. Whether or not you're in a big space or a small space when you do the recording, it's still going to probably end up a little bit dry. So what if you, as the audio engineer, wanted to make that vocal sound like it's coming from a big cathedral, or wanted to make that vocal sound like it's coming from the Grand Canyon, or something, you know, a large space or even a small space? What if you wanted to make that vocal sound like it's coming from a locker room, right? Because you just wanted to get that kind of that sound. Well, you can use reverb to make that happen. And so reverb is basically the dimensional space. Is creating and crafting a dimensional space. And what it does, it gives you some kind of a depth, right? But essentially what you're doing is you're trying to manipulate and craft acoustics. And that's really what reverb is. And there's different tools and different parameters on a reverb to craft that space and the way you want it to craft it. So you can make it a big space, you can make it a small space. You can make it a bright space, right? So a bright space would be something that has a lot of bright reflections, maybe like a glass and marble or something like that, who knows? So that's kind of what reverb is, and that's what we're going to be talking about today. So when we use reverb, we're going to be using plugins, but there was a time in music history recording that we didn't have any computers or we didn't have any plugins, right? And so how do they craft those reverbs back in the day? Well, they use something called reverb chambers. So let me go ahead and open up this attachment here. So Abbey Road Studios, Sun Studios, very famous studios that have reverb chambers. And what this is basically a dedicated room somewhere in the building of the studio where you have, you know, some hard surfaces and some good reflections going on. So in this case, you're seeing a reverb chamber over here. They have, looks like they have cement ground. They have some tile for the walls over here, right? Or for this wall in particular. And they got these cylinders used to kind of reflect sound within the room itself. And so the way we were able to use this when we had a dedicated room was we would have the console. And if you had instruments on the console, let's say you're mixing, you can send that specific instrument or whatever instrument or vocal that you want, and with a click of a button, and you twist a knob, and that instrument goes from the console all the way down to the building of this room, this reverb chamber. And then that instrument will be playing from these speakers, and then basically you get the reflections of whatever instrument is being played from these speakers within this room. And then in order for us to actually capture the reflections within the space, we have to record it with a microphone. So there's a microphone in this reverb chamber that actually picks up the reflections, and that goes back into the board so we can actually record the sound of the reverb chamber. And so reverb chambers are, different in size. There's different materials in the reverb chamber, but this is the natural way of recording reverb before the days of digital plugins. And even till this day, a lot of engineers will swear to you that reverb chambers sound a lot better, and I can see that because it's a natural way of creating reflections, because you're actually using real surfaces. It's not algorithms or anything like that. So studios that have reverb chambers are often sought out for, and that's really cool. And then after the whole chamber aspect, we decided to make things a little bit more convenient for us, and use something called plate reverb. So this is a very famous plate reverb. It's called the EMT 140. And it's basically this big metallic box, right, that you can store. You don't have to have a dedicated room, but you can store this somewhere inside of the studio that's away from the console and the speakers and all that kind of stuff. So this will go into the machine room or some other kind of room. But basically is you take sound from the console, instruments, vocals, whatever the case is, and you put them into this box. And inside this box is a bunch of metal kind of surfaces. So, and there is a speaker in here as well. And so when the sound goes into the box, it reflects from those surfaces within the box, and you get this big metallic kind of reverberated sound. And then you record that sound back into your console, and that's what the plate reverb. So why is this important to understand? Well, if we're not using these kinds of reverb in the studio, right, why is this important to understand? Because a lot of the digital plugins emulate these sounds. So if you're using some plugins in Pro Tools, there might be a setting called plate, and if there's that setting called plate, then it's really mimicking what this is, right, the EMT 140 plate or some other kind of plate reverbs that are out there at the time. If you have a button on the reverb plugin, it's called chamber, then it's mimicking the chamber that we just discussed previously. So it's good to know the history of reverb, because oftentimes the plugins are trying to mimic that, and now you know kind of what's going on, right? And then, of course, that segues into the next thing that we're going to be talking about, is basically the digital aspect of reverb. So this is the real analog EMT 140 plate, the hardware, the metallic surfaces. But then digital reverbs came along and they said, hey, look, let's try to make a digital version of that so everyone can use it and they don't need to have an EMT 140 plate in their bedrooms or whatever. So this wasn't created, this plugin wasn't created at the time, but it was created a lot later, maybe like in the early 2000s, mid 2000s, something like that. But this is the plugin version of the EMT 140 plate. And so you can buy this, get it on your computer and use it, and it's going to sound pretty close to the real thing. And I have this, and it sounds amazing. I enjoy using this plugin quite a bit sometimes on vocals, especially for singing. So this is that. And then the reverb that we're going to be using for this specific class that comes with Pro Tools, the stock reverb plugin, is the Deverb, right? And you can see over here that it has a plate setting, right? So that's important to know. And then later on when we talk about reverb parameters, we'll talk about what some of these buttons do over here. So that's really the history of reverb, right? The chambers, the plates, digital reverbs. There's also something called spring reverbs. A lot of guitar players like to use those. So that's what that is. So let's go ahead and minimize this here, and let's move over to acoustics. So in order to understand how reverb works, we need to understand the acoustics of any kind of environment, whether it be big or whether it be small. And every time you're listening to something in any kind of environment, you're listening to three things at the same time. You're listening to the direct sound, the early reflections, and then the reverberation, right? So these three things are happening simultaneously all the time. Even as you're hearing me right now, these three things are happening, right? So the direct sound is the direct sound. So I'm going to go ahead and open up this, and it's going to make a lot more sense when you see this diagram over here. So we have in this diagram the sound source, which could be like a guitar, it could be whatever it is, whatever is causing the sound, right? And then you got the listener over here, right? The direct sound is the direct sound coming from the sound source to the listener. So no reflections, no reverberations, is just going directly from the sound source to the listener. And that gives you, clues about where the sound is coming from, the location, the tonality of the sound, how big it is, right, and that kind of stuff. So that's really what the direct sound is all about. They call it direct signal over here. Now, that's the dry signal, right? And why is that important? Because in a lot of, I'm going to go back here, a lot of plugins give you the option to blend the dry and the wet signal. So if I took this little bar and I put it all the way to dry and this 100 becomes 0%, you're not hearing any reverberation. You're just hearing the direct signal, the direct sound. And so that's all it is. As soon as I turn this up, you're going to start to hear the early reflections and the reverberation. So that's the difference between dry and wet. So if you have something at 0% or dry, all the way dry, you're not hearing any effect. As soon as you turn it up from 0 to like 10 to 20% to 30 to 100, whatever the case is, you're hearing more wet and more wet of the signal. Wet means the affected, the effect, the impacted, the impact of the signal, right? The reverb. So that's kind of what that is, dry and wet. And that's important to understand. So let's go back to this. And then you have, from the dry signal, the early reflections, right? So early reflections are tricky because we often we don't hear those. And we often think that the early reflections are part of the direct sound. And because the signal from the early reflections are happening so quickly, right, in the milliseconds, we often think that is part of the direct sound when it's actually not. And so that whole phenomenon is called temporal fusion. The idea that the early reflections are so close with the direct sound in terms of time that we often think that it's part of the direct sound, but it's not. Right now, you're listening to early reflections from my vocal, but you may not realize that, right? You're hearing the direct sound from my mouth to the microphone, but you're also hearing the reflections that are happening right next to the microphone as well, and you can't really see it. But I have hard surfaces on my desk, right? I got like a little mixer over here. I got all kinds of hard surfaces over here. And so whether or not you know, my voice is bouncing not only directly from my mouth to the microphone, but is bouncing from the hard surfaces into the microphone as well. And that's impacting the signal of the microphone. So if you really, really, really want a dry recording, you need to be in a vocal booth, right? Where it's completely dead, absorbent, no reflection. And that's going to give you like one of the most direct sounds that you can possibly get, where you just really hear the quality of the microphone and the vocal. So even in this environment right now, as close as a microphone is, you're still hearing the early reflections. And depending on the environment, if you're recording drums in a very fabulous, amazing room with nice wood floors, and all kinds of good acoustics, then those early reflections can definitely help you out. But if it was the opposite, where like you're not in a good environment, those early reflections can definitely not help you out. So that's kind of what that is, right? And then past the early reflections, past that, that millisecond time, you're going to get the reverberation. And usually they say it's about 30 milliseconds or so, but I think it depends on the sound envelope. If the sound is a short sound or a long sound, I think it really depends. But past the early reflection time is all the reverberation, and this is what you think about when you think about reverb and the space and all that kind of stuff. Reverb is not synonymous with echo. Okay, so that's one thing that you should know, because echo implies that you hear a dry sound, then you hear the wet sound after, right? And you get that repeated echo. That's more of a delay and not so much of a reverb. If you were in a cathedral and you said hello, or you clapped inside of a cathedral, you're hearing that instantaneous reverb that's happening within the room itself, and that's reverb. And that's the dimensional space, and it happens because of the acoustics of the environment. So that's what that is. So those are the three parameters, or not the three parameters, but the idea of acoustics, right? Now let's go ahead and dive into the reverb parameters, which is very important. So these are the knobs and the buttons, and most reverbs that you're going to get have a decay time, a pre-delay, and a diffusion. Now this is one of those things where like I'm going to talk about it and it may or may not make sense. I mean, it might make sense conceptually, but you need to see it in action for you to actually hear the differences, and that's what the demonstrations are for. So below on the demonstrations, you're going to see a couple of videos. One is going to be about decay time, the other one is about pre-delay. Which those two things you can hear a lot better than the diffusion. Diffusion is a little bit tricky. So decay, pre-delay, diffusion, you're going to see that over here on this plugin that we're going to be using for this class. And you see it right here. So decay time, pre-delay, diffusion, and those are what those knobs are. And even on this one, I believe this one also has a decay time and a pre-delay as well. It does, absolutely. So this is, they call it reverberation time, but you could change the decay time over here using this plus and minus buttons. And then you have pre-delay somewhere over here, right here, all right? So it goes all the way up to 250 milliseconds. And so we'll talk about that, right? We'll talk about what those numbers are and what exactly it is. So decay time. So imagine that you are in a room, and like a cathedral, and you clap your hand, and that clap of the hand lasts like 3 seconds long. That's your decay time, is how long it takes for the reverb to disappear, quote unquote, right? So you clap your hand inside the cathedral, the hand clap lasts 3 seconds. That's a 3 second decay time. So I go to my decay time knob, I turn it up to 3 seconds, and boom, that's a 3 second decay time. Now, specifically audio engineering technical terms, the definition of decay time is what we call RT60, reverb time 60. So it's how long it takes for the initial volume of that clap to drop down by 60 decibels. And that's what we do. Like if we went out there to create algorithms and create what we called convolution reverbs, which is based off like real recordings in cathedrals, and that's what you use in your plugins. We measure that kind of stuff. So that's important, right? And what does the decay time tell you? So how is this practical? What kind of information does the decay time give you? It gives you clues about the size of the room. So if you got a big room, you get a big decay time, but it also depends on the material that's in that room as well, right? So if you have a big room and it has hard surfaces like marble, maybe wood, glass or something like that, you're going to have a much bigger decay time. Whereas if you had a big room, but you had a lot of absorbent material, you could think about a theater or something like that, right? Where you got carpet, drapes, and all that kind of stuff. Your decay time is not going to be that long, even though the room is big. So it gives you not only about how big the room is, but what kind of material is in the room as well. So that's the whole thing about decay time. And this is your a graph about decay over here. And is basically giving you the idea of RT60, how long it takes for the reverb to go from here all the way down to 60 dBs, and that's really your decay time. You have here the early reflections, and then the reverberations over here. They call it clutter. We'll talk about this delay time that they're talking about over here, but that's what we call pre-delay. But this is a graph kind of showing you RT60 over here. If this doesn't make sense, I'm not really worried about that. But just know that the decay time is how long it takes for the reverb to disappear. This graph is showing you the initial point and the loudest point of that, source to the lowest point, which is the minus 60 dB point, right? And this is the time it takes for us to get there, and that's your decay time right there. So, all right, let's go ahead and get rid of that. Okay, so then we got the pre-delay. All right, so the pre-delay is how long it takes for your reverb to start, right? So let's go back to our deverb that we're all going to be using, and let's say we set our pre-delay time to, let's say, 20 milliseconds. So what does that mean, right? I set my pre-delay time to 20 milliseconds. What does that mean? That means if I set my pre-delay time to 20 milliseconds, that means that I'm going to hear the sound first, and then 20 milliseconds later, the reverb is going to kick in. Right? So that's what that is. And where does this make sense? Like, what's the whole thing about this? This also gives you clues to the dimensional space. It also gives you clues to the material of the room. Right? So bigger rooms have longer pre-delays. Smaller rooms, not so much. But more importantly, it's also about where you are in the room in comparison to the sound source. So let's take a look at this here. If you want your reverb to not sound super reverberated and super washed out, and you don't want, because what reverb does is it's not a left and right thing. Reverb gives you depth. It gives you the front and rear. If you want somebody to be more rear in the mix, like, in the back of the mix, you could put more reverb on them. But what if you want reverb on a vocal without them being pushed back? Well, then you could use pre-delay time. So check this graph out. This is the sound source, and this is the listener, right? And so you have the dry signal over here, right? And then you got a reflection happening over here. Well, take a look at this. You got the dry signal happening pretty much right away, and then the reverberated or the reflected signal happening a lot later in comparison to the dry signal. So this is showing you that this is a longer pre-delay time, right? You got the original source, and the delays, the reverb's kicking in a lot later because you're so close up to that original source. Whereas this one, you're all the way back over here, right? So the listener's all the way in the rear. So you got a sound source, the original sound, traveling from the source to the listener over here, and the reflected sound kind of happening at the same time. I mean, it's not exactly the same time. It looks like this might be a little bit longer, but it's not a drastic difference in comparison to this one, right? This and the reflected is a lot more bigger in gap in terms of time in comparison to this one. The amount of time it takes for the source to go to the listener is almost equal to the reflection. So this is a lower pre-delay time, right? So like I said, pre-delay actually puts the source up closer to the listener, and that's what you're seeing over here. So, you know, when you listen to music, and I talk about this mix all the time, Sway Lee and Post Malone, what's that song? The Sunflower Song, mixed by Manny Marroquin, a Guatemalan, born mixing engineer, one of the most famous mixing engineers out there in the world. He likes to use reverb on their vocals. I mean, Post Malone uses a lot of reverb on his vocals, and so does Sway Lee, all those singing kind of rap music. But he does it and crafts it in a way where he doesn't put those singers in the back of the mix. Those singers are still in the front. And I think what he's doing is he's using some sense of pre-delay as well. So pre-delay is a good way to use reverb without pushing the source in the back of the mix. And it's a great tool, especially if you're using music production. But you could think about pre-delay also in the real world. Like, if you go to a stadium or if you go to the Grand Canyon and you start yelling, right, you're going to hear that yell like 50 milliseconds after, right? So you're going to hear your dry source first, then maybe 50 milliseconds after you're going to hear that, what we call echo, that delay. And you could think about that as pre-delay as well. So there we have it. And then diffusion is a weird one, and it's hard to hear sometimes, but it's basically how a sound gets reflected back. So you can either get a reflection back from a absorbent material like a drape, where it reflects sound back but not as much, or you can get a reflection back from a glass. And some reflections are more dense than others, right? And so if you want your diffusion to sound really dense, then you go all the way to 100%. And if you want your reflections to sound a little bit thinner and a little bit brighter, you turn your diffusion down to 0%. So it's the way sound reflects back to you, the manner. It is really the density of the reflection itself. So here's a diffusion. 100% means you have a dense sound, a dense reflection, and then at 0%, your reflection is not as dense, and the reverb sounds a little bit more brighter. So that's kind of what that is. A little bit more thinner, I should say. So that's it. I know that, this was great to talk about the definition, the chambers, and the acoustics and all that kind of stuff. But when it comes down to the reverb parameters, right, like decay time, pre-delay, and diffusion, definitely going to want to use it to really get a good understanding of it. But now that you know it on a conceptual level, you can go to the plugin and start using it and know what it is and know what it refers to, right? So below this, there's going to be demonstrations, and I'll talk about decay time and pre-delay specifically, just to show you and demonstrate how those things are used. Anyway, I hope this helps, and I definitely hope this helps with the project. And if you have any questions, feel free to let me know, and I hope you have a nice day. Thank you.